Hello everyone, welcome to another uh, episode from Mughal Pharmacy. And in this lecture, we will be discussing about the mechanism of action of sulfonamides. Okay, if we actually start the mechanism of action of sulfonamides, uh, first we have a brief discussion about the cellular machinery of bacteria, that how DNA of bacteria is synthesized, because sulfonamides are DNA synthesis inhibitors. So in the bacterial cell, the two compound para-aminobenzoic acid is the one compound, and the structure of para-aminobenzoic acid is this one. And a pteridine is another compound. These two starter molecules are responsible for the synthesis of the DNA through different steps or through different pathway. Para-aminobenzoic acid and pteridine. Pteridine is basically a heterocyclic compound, and it is made up of two fused rings. The one ring is pyrimidine ring and other one is pyrazine ring. Both are 6-membered ring with 2 nitrogen, but the position of nitrogen is different in these two fused compounds. One is pyrimidine and other one is pyrazine. Okay. And this para-aminobenzoic acid is also called as PABA. Okay. Para-aminobenzoic acid plus pteridine this pteridine combines with each other and a new product is formed. And the name of the new product is dihydropteroate acid. Dihydropteroate acid. And this conversion of para-aminobenzoic acid and pteridine into dihydropteroic acid is catalyzed by an enzyme that is called as dihydropteroate synthase. Dihydropteroate dihydropteroate synthase. This is an enzyme. Okay. After this step, this dihydropteroic acid is converted into dihydrofolate. It is converted into dihydrofolate. Dihydrofolate. Folate. So definitely this conversion of dihydroteroic acid into dihydrofolate is catalyzed by another enzyme that is called as dihydroteroate reductase. Dihydroteroate reductase. Reductase. And it works on this step. And this dihydroteroate synthase work on this step. This is step number 1 and this is step number 2. So after this step number 2, there is another step in which this dihydrofolate is converted into tetrahydrofolate. Tetrahydrofolate. And this conversion of dihydrofolate into tetrahydrofolate is supported by an enzyme that is called as dihydrofolate reductase. Dihydrofolate reductase. And this is step number 3, where dihydrofolate is converted into tetrahydrofolate by this enzyme. And this is step number 3. Okay. Tetrahydrofolate is responsible for synthesis of DNA. And we all know that DNA is made by different bricks, and those bricks are nitrogenous bases. Nitrogenous bases. And those nitrogenous bases are purines and pyrimidines. Purines pyrimidine. In this way, DNA is synthesized. So here the question arises that how tetrahydrofolate is going to make the nitrogenous bases like purines and pyrimides. This tetrahydrofolate uh, provides some functional groups, provides some functional groups. Those functional groups are responsible for the synthesis of purines and pyrimidines. For example, methyl group, methyl group, methyl group. The second one is methylene group, methylene group. The other one is methinyl group, methinyl group. And other one is formyl group, formyl group. So these groups are provided to these nitrogen bases and their synthesis is completed, and after that DNA is synthesized. So this is the cellular machinery that how bacteria synthesize its DNA through different constituents and the conversion of different constituents from one product to another product, and ultimately DNA is synthesized. Okay. Now, what basically sulfonamides are going to do? Sulfonamides are actually the analogs of para amino benzoic acid or PABA. P A B A. Para amino analogs of para amino benzoic acid. These are not actually para amino benzoic acid, but similar to that of para amino benzoic acid. So when sulfonamide approaches the bacterial cell, these sulfonamide drugs compete with this para amino benzoic acid, and at this place compete with para amino benzoic acid, and instead of combining the para amino benzoic acid with pteridine, sulfonamides gets combined with pteridine instead of actual para amino benzoic acid. In this way, dihydroteroic acid that will be formed will not be true dihydroteroic acid because it has the impurity of sulfonamides in its structure. So when dihydroteroic acid is pseudo in nature, definitely dihydrofluid will also be pseudo in nature or will not be true in nature because of sulfonamide impurity. So in this way, this sequence will keep on moving, and tetrahydrofolate will also be a pseudo tetrahydrofolate. Okay. And when pseudo tetrahydrofolate will be formed, definitely it will not be able to provide its methyl group, methylene group, methionyl group, and formyl group to the purine and pyrimidines to their synthesis. Or if somehow tetrahydrofolate provides its group to the synthesis of purine and pyrimidine, those function groups will not be true. So in this way, true pyrimidines and purines will not be formed, and the DNA which will be formed will be fake in nature or pseudo in nature. In this way, DNA synthesis of bacteria will be halted. So this is the first mechanism. The other mechanism is that the sulfonamides, the sulfonamides sulfonamides inhibit this dihydropteroate synthase. This is the second mechanism. This is the second mechanism. So definitely when dihydropteroate synthase will be blocked by sulfonamides, all the rest of the products will not be formed because one step has been halted, or step number one is blocked by sulfonamides. Dihydroteroic acid will not be formed, dihydrofolate will not be formed, tetrahydrofolate will not be formed, and in this way DNA will not be synthesized because purine and pyrimidines are not synthesized. So this is the brief mechanism of action of the sulfonamides. So let's recap. In the bacterial cell, there is para-aminobenzoic acid and pyridine. Para-aminobenzoic acid is just like that. Benzoic acid, and if we introduce the amino group at the para position of the benzoic acid, it becomes para-aminobenzoic acid. And the other compound is pyridine, which is heterocyclic compound. It is made up of two fused rings. One is pyrimidine and other one is pyrazine. So para-aminobenzoic acid and pyridine gets fused with each other and converted into dihydroteroic acid by the activity of an enzyme that is called as dihydroteroate synthase. So this is the first step. In the next step, dihydrofolate is formed by the activity of an enzyme that is called as dihydroteroate reductase. In the next step, dihydrofolate is converted into tetrahydrofolate by the activity of this enzyme, dihydrofolate reductase, and this tetrahydrofolate provides these functional groups to the purine and pyrimidines because these functional groups are necessary for the synthesis of purine and pyrimidine, and in this way DNA is synthesized. So this is the cellular machinery of the bacteria, that how DNA is synthesized. What sulfonamides are going to play with bacteria. Sulfonamides are analogs of para-aminobenzoic acid. So they compete with actual para-aminobenzoic acid and they gets combined with pyridine. So in this way, pseudo dihydroteroic acid is formed. Ultimately, pseudo dihydrofolate is formed. Ultimately, pseudo or not true tetrahydrofolate will be formed, and it will not be able to provide its all these four groups because it is not true in nature. And in this way, true purine and pyrimidines will not be formed, and a true DNA will not be formed. In this way, DNA synthesis of the bacteria will be fake in nature, and bacteria will not be able to survive because of fake DNA in its cell. This is the first mechanism. In the second mechanism, sulfonamides are going to inhibit this dihydropteroate synthase. When this dihydropteroate synthase will be blocked, the conversion of para-aminobenzoic acid and pteridine will not be spotted into dihydropteroic acid. So all the rest of the products will not be formed and ultimately DNA will not be formed. This is the mechanism of action of sulfonamides. If you people enjoy this lecture, please do me a favor, like, subscribe, and share. Thank you very much.